Hey, welcome to the Flipped Classroom for AP Calculus. This is on section 2.4, it's session 15, derivatives of trigonometric functions. Let's talk about the derivative of sine of x. To find this derivative, or to come up with an expression for this derivative, we're going to use some trigonometry. First, you may remember that the angle sum identity equals the following. The sine of x plus h would be the sine of x times the cosine of h plus the cosine of x times the sine of h. Also, from previous sessions in this class, the limit as h approaches 0 of the sine of h over h equals 1, and the limit of the cosine of h minus 1 over h as h approaches 0 would equal 0. Let's take the sine of x, the limit of the sine of x, and express it as the formal definition of our derivative. So the limit of the sine of x plus h minus the sine of x all over h as h goes to 0 would equal the derivative of the sine of x according to the formal definition. We can do some algebraic manipulation of this by just simply using the angle sum identity, and that would be the limit as h approaches 0 of the sine of x times the cosine of h plus the cosine of x times the sine of h minus the sine of x all over h. Now, if I find a common factor in two of those terms, namely the sine of x, I can factor that out, and I get the sine of x times the quantity cosine of h minus 1 plus cosine of x times the sine of h all over h. I can break that into two separate limits using the properties of limits, and I would get the limit as h goes to 0 of the sine of x times the quantity cosine of h minus 1 all over h plus the limit as h goes to 0 of the cosine of x sine of h all over h. The next slide continues this process. So now what I have is the limit of the sine of x as h goes to 0 times the limit of the cosine of h minus 1 over h as h goes to 0 plus the limit of cosine of x sine of h all over h. Okay? Well, the limit of the first part is simply 0 because the limit of the cosine of h minus 1 over h by our previous proof would be 0, and the limit as h goes to 0 of sine of x is just the sine of x. 0 times the sine of x would be 0. Okay? The second part, the limit would be, I'm going to split that into two limits. The limit of cosine of x, okay, times, using properties of limits, the limit of sine of h over h. Okay, well, the limit of cosine of x as h goes to 0 is just cosine of x because there is no h term, but the limit of sine of h over h as h goes to 0 by a previous chapter is 1. So therefore, our final answer is 0 plus cosine of x times 1 of cosine of x. So the limit of the derivative of the sine of x would be simply the cosine of x. The derivative of cosine of x is negative sine of x. And this could be derived in a similar way as we just did for the derivative of the sine of x, but we'll leave that as an exercise for the reader or the listener or the watcher. Derivative of tangent x. Well, the derivative of tangent x, quite simply, is the secant squared of x. You can think of tan x as sine of x over cosine of x. If we use the quotient rule, we can find the derivative. Let's let h of x equal the tan of x, so therefore h of x equals sine of x over cosine of x. H prime of x, using quotient rule, would be cosine of x times the derivative of the top, which would be cosine of x, minus sine of x times derivative of the bottom, which would be negative sine of x, all over bottom squared, or cosine of x squared. Okay, The top of this expression simplifies to be cosine squared of x plus sine squared of x, and that would be divided by cosine of x quantity squared. You may remember the trig identity that says cosine squared plus sine squared equals 1, so the numerator simply becomes 1, divided by our bottom, which is cosine squared of x. 1 over cosine of x is the secant x, so this fraction would simplify to secant squared of x, and that would be the derivative of tangent of x. Pretty easy. Next slide will give us a table of all the trigonometric functions and their derivatives. So I've already listed sine of x would be cosine of x, secant x is secant x tan x would be secant squared of x, cosine of x would be negative sine of x, cosecant x, its derivative would be negative cosecant squared of x, cotangent x, its derivative would be negative cosecant x cotangent x. Notice, derivatives of the co-functions are always negative. That's an important thing to remember. The derivatives of the co-functions are always negative. Today we'd like you to practice on 184 to 185, numbers 1 through 30. Thank you and see you in class. Bye.